development process in which we have used this reduced form of graphene oxide as a nanomaterial. Then we have used this CF, that is carbon fiber of 200 GSM, and other material as epoxy or matrix and hardener. So this one is the properties of the material which we reinforcement. Just carbon fiber is only act as a reinforcement, and secondary reinforcement percentage is 0. So that's why here's the 0, 0 is the RGO value is mentioned in this tabular form. And then we have this 0.5 weight percentage of RGO, and then 1 weight percentage of RGO in CFRP. So total we have considered 4 different types of composite laminates. And this one is that various types of characterization process. Actually, what we have developed, it should be characterized or it should be tested. So for that purpose, we have used different types of advanced testing process in which SAM is there, EDX is there, XRD process is there, DMA, that is dynamic mechanical analysis, then UTM is for this tensile flexural compression, then ISO impact test, which we have performed. So this one is the SAM analysis of that is the microscopy analysis of reduce that which we have synthesized into this epoxy matrix. So here the RGO flex is identified in this our SAM micrography testing. So which shows the uniform dispersion of the material in this matrix. That is our polymer epoxy matrix. So this one is a further analysis. Advanced version of the SAM is that is the transmission electron microscopy we have used, and here the presence of this nanoflex is also which shows the proper dispersion, or which shows a confirmed present of this RGO nanomaterial. And further, we have performed this elemental study in which we have identified different types of elemental presence in this proposed material, that is RGO reinforced CFRP. Then further, we have performed this XRD. So this XRD in which we have studied about the internal structure, that is also known as D-spacing between the material. So this shows the different types of peaks which confirm the presence of this reduced form of graphene oxide. So further, we have performed this DMA test. So these are some advanced testing which we have performed. And important one is this DMA in which we have studied about the glass transition temperature, which is mainly applicable for this high performance application where what a very high temperature of about more than 200 or 250, 280 degree types of temperature is there. So for that purpose, we have also performed this glass transition temperature study. And after that, these are the conventional testing process in which all types of material which are developed, it should be tested through this mechanical testing, in which tensile test play a very important role. So we have performed about 3 sample or 3 reading we have considered for different sample, and finally we have taken the average, and that average value is our final value for this a single reading type of test. So for a single reading, we have performed 3 types of repetition of the test, so that our result should have a less error. And these are the interesting result which we have achieved, and we have observed that in a pristine sample, the tensile strength is about 505 MPa and tensile modulus is 8353. So these are interesting results which we have achieved. And most important one is what we have considered different types of configuration. Then which one is the best configuration? This one is very important. So this we have also used some what parametric analysis or optimization of the different parameter to identify a optimal loading of the material. Testing, and we have analyzed the microscopy test for this all types of samples under this mechanical testing process. So this one is the summary of the previous chapter or previous phase, that is the synthesis and development phase. So here after if efficient synthesis process in which we have used this vacuum assisted resin transfer molding process, and other conventional processes are also there, but in most important or significant point of study in this vacuum assisted resin transfer molding is what the different types of defect, the manufacturing defect in which such as blow holes is there, air is entrapped during the manufacturing process. So these types of defect are not available in this resin transfer molding process. So this one is very highly efficient process for the development of the laminated polymer material samples. So other process might have some limitations in which some moisture content is there. Synthesis and the development. After that, we have tested the material. That tensile test is there, iode impact test is there, and different types of advanced characterization is there in which TGA, DMI, FTIR, XRD we have performed. So these are the testing of the material, and testing result shows that this material is suitable for this high performance application. But most important one is what? Uh, able to obtain different types of shapes and styles. It should be able to sustain at a high temperature, at a high pressure, and should be capable to tailored into desired shape. What type of shape we want, it should be adaptable in that shape. So this one is very important. So tailoring properties play a very important role. If we assume our mobile in which a microphone is fitted inside that our this Android phone, and there is one hole. So how that hole is generated, this one is the interesting and a very interesting thing. So the micro machining process or micro drilling process are performed to generate these type of hair like structure shapes. So these type of what slots, these types of micro holes or different types of very minute channels are developed in prosthesis, implant, dialysis type of apparatus. So these types of shape generation lies under the machining process. So that's why to evaluate the manufacturing efficiency of the material we have, it is mandatory to evaluate the machinability aspect. So for that purpose, we have performed two very versatile machining process, in which drilling process we have performed on our material, and second one is the milling process we have performed on our material. And third important one, after these tailored properties, after these machining properties, we have developed the filament of these material for the additive manufacturing process. So number of laminates are developing nowadays, but important thing is what, that material should be capable for the additive manufacturing applications or filament. For this filament we have developed of these materials. So at the end I will show you the filament development process. So before in that there is an intermediate phase, that is the machining process. So for that purpose we have performed this milling process. So this one is the experimental setup which we have considered for this machining process. So here we have used this lathe machine for CNC lathe machine for the generation of different types of slots. In milling, what slots and channel are generated under this milling process. So this one is further the brief information about this the setups which we have used. Now, what type of parameters or how many parameter we have used? So during experimentation or during any types of machining process, there should be statically balanced. Design of experiment should be there. So we have considered a very statical balance DOE type of structure, and then on that uh, uh, what statically balanced design we have performed this milling process. So these are our parameter in which weight percentage, spindle speed, feed rate, DOC. These are the parameters, and we have varied these parameter at what different labels. So this one is the what? this observation which we have achieved through this design of experiment. So these are our experimental results in which we have observed this material removal rate, cutting temperature, and then surface roughness. So these are the what quality parameter or productivity parameter. These types of response will finally define the quality and productivity aspect of the this machining process. So these are our results which we have achieved the SN ratio for all the what this response are found satisfactory. And this was some mathematical analysis. Sometime the what the interrelation between this parameter and response, which we have elaborated with the help of this analysis of variance. So ANOVA, which we have performed. So that this one is the temperature profile, which we have performed this non-contact type of infrared thermometer, which we have used this assessment of this temperature generation during this milling process. So these are thermographic infrared images which we have achieved, and further we have explored these images with the help of some what this analysis, different types of analysis process between this 3D surface plots we have generated to analyze this temperature study versus different types of parameters. So this one is the what we have also find out what the best parameter or optimized parameter setting. So here we have achieved the optimal parameter setting at that 1.5 weight percentage shows a satisfactory what results in this machining process also. Previously, we have achieved also the best result at this what graphene oxide into this CFRP. And during the machining or during the milling process, we have achieved this. So this one is also validated through this optimization technique, that is GA. And this one is the confirmatory test. So confirmatory test also shows that there is where error of about 9.09 is achieved. So it is less than 10. So this shows the adequacy of the perform experiment in a satisfactory level. So this one is the improvement in the various responses which we have achieved. And finally, we have optimized these results with the help of one technique that is known as Codas technique. So this confirm that 6 number of experiment is the optimal set of parameter among 9 number of this perform test. And finally, we have also what validate these type of optimal setting or predicted setting with the help of this microscopy image analysis of the what response which we have achieved, or the simply the analysis of MRR surface roughness which we have achieved. So these confirmatory tests also validate that the perform experiment is in a satisfactory range, and what we have achieved that the loading of these 1.58 percentage of this RGO is satisfactory for this CFRP physiomechanical performance properties analysis, and from a machining point of view also we have achieved this optimal setting. So this one is the brief summary about the one process, that is the milling process. So during the milling process, we have observed that the error rate is also under a control process. So these two processes are the most important process. We know that any type of structure is not possible without these two processes. So these are the fastening and joint process, which is widely used for assembly of any type of structure. So without drilling, any type of structure development is not possible. So that's why we have considered this drilling as very important process during our investigation of this nanocomposite machining process. So during this drilling process, we have analyzed the drilled surface. That we know that in different types of heavy structures, the nut and bolt type of what assembly is there, and joining process is there. Sometimes we are using this welding process and seamless type of joining process also, in which these types of joining process, this welding is the most important process. So that's why we have explored and we have studied the welded, the drilled surface which we have achieved And the drilling efficiency evaluation is also performed in this test. So this one is the setup for this drilling process. CNC drilling we have used, and this one is a brief specification about the drill bit geometry. So these are the results which we have achieved through this drilling process, and different types of what apparatus we have used. So digital optical microscopes we have used, and image software for this image processing technique. So drilled hole is analyzed with the help of this digital image processing technique. So and dynamometer is used for the analysis of this three different types of holes. So this one is the what drilling experiment or domain of the experiment. So total here we have again used three different types of replicate for each experimental run. So most important one is what, how we can say that our material have highly efficient drilling. So it is analyzed here. We have statically analyzed with the help of this Burr area formation analysis. So very limited studies are available on this Burr area formation. So most important one is what is Burr area? How we can define this Burr area? So Burr area are the uncut fiber during the machining process. Sometimes we are what? Perform a drilling operation for the whole generation. We have generated a hole, but still there are some uncut fiber which are fragile in nature, and these fiber have very high strength. So mathematically, we have analyzed this Burr area formation. So these are the what responses which we have achieved. So here we have performed this box Mencken design based 15 number of experiment, and four important response we have analyzed here, in which thrust, torque, surface roughness, and Burr area formation we have analyzed. So these are the force analysis of this during the drilling process. So first one is the primary phase, intermediate phase, and then third one is the secondary phase. So during the intermediate force, the amount of force generated is higher, which can also causes a rapid tool wear during a high force. So further, these are some mathematical interpretation of the our responses with the help for this average surface roughness. So finally, we have analyzed our material, the drilling process in two different aspects. First one is what we have performed these drilling operations, and we have measured this thrust force and temperature and these different types of tangential forces in the our study. Secondary important aspect, we have also analyzed the force analysis with the help of some software, and we have used this image software for the generation of different types of images which are observed during the each number of run. So total 15 number of different experiment we have performed on four different types of samples. So these are some 15 different images which I want to elaborate here with the help of some images. So here all uncut fiber is there. So in which experiment number 2 have very high number of uncut fiber, 3 have also 5. But if we observe the image number, what this 8 and this 9. So the hole is very precise. Hole is very accurate. So there is very less, very minute fiber is there. So this shows a drilling efficiency of our material. So the experiment number 6 is our best experiment, in which is highly the drilling efficiency is very higher. So experiment number this 9 which we have observed a very high drilling efficiency, and similarly the other experiments such as experiment number this 3, experiment number 2, and finally we have this experiment number 13. And if we observe this experiment number 15, very high amount of uncut fiber is there. So these are what? These are inefficient drilling process, but if we observe this experiment number 5, so this one is the efficient drilling process. Further, we have analyzed this Burr area formation with the help of some of these 3D plots, and then the R square we have estimated here to evaluate the model adequacy of the our perform experiment, or the correlation between the parameter and the response. So here we have analyzed. Further, we have use this DFA. Sometimes it is also known as this DFA in short form, the desirability function analysis. We have considered here for the optimization purpose. So finally, we have this responses, the optimal responses. So experiment number 6 is our optimal response, which we have achieved. And we have also validated this response through various optimization technique also. And experiment number 15 have the highest Burr area formation. So this one is what? This one is the worst condition which we have faced during our drilling process. And further, after this statistical analysis and some mathematical correlation between the response and the parameter, we have used this digital image processing technique. And further, we have analyzed this what high resolution scanning electron microscopy to investigate the machinability behavior or the surface analysis of the drill hole. So these images are the same images of the what this drilled surface, which is mainly performed to evaluate this uncut fiber presence in our study. So this same image shows that some matrix depletion point, which is encircled by these yellow types of lines, and red lines also shows that some defect are generated, some debris formation is also there due to this uncut fiber, which is deposited in the machine surface, and some minor types of cracks is also observed in this SAM test analysis. And further, the higher if we what zoom out that SAM image, and during zoom out we have observed this image further at very high resolutions. So this image shows that the experiment number 6 is validating experiment. So these two image witness that the drilling efficiency of our material is very higher. So both type of machining process validated that milling efficiency is very higher, drilling efficiency is very higher. So this we want to achieve, that whatever we have developed, it should be machinable. Now, from these both study, we can say that machining efficiency of our material is a very desirable point of view from the industry, that the industry which they are also searching for highly machinable, machinability material. So our this characterization of the material, that is the initial phase after the development, validated the result by different types of mechanical testing, tensile testing, and different types of TGA, DMI, TIR, and some other advanced testing is also there. So initially result is validated with the help of what characterization process, and then further we have validated the performance of our material with the help of this machining process. Now, if we now we can say that we have achieved the higher machining efficiency. Now, next important phase is what? Now, development of the product. Machining is now satisfactory, development is now satisfactory, synthesis part is satisfactory. Now, what we want to achieve through this material, where we want to use our material. So this one is very important. So I have focused towards this additive manufacturing process. So these materials, these polymer materials are easily converted into different types of shapes. But from additive manufacturing, fused deposition modeling, we need filament for 3D printer. So for the development of this filament, very limited what investigation, very limited examination are available on the filament development of these types of, that is the what type of wire is what wrap. So this one is the HDPE wire which we have developed. About 1.25 mm dia is used, and we have also different shapes of die for the development of what different dia of this 3D printed filament. So this material, this polymer material in which this CFRP, GFRP, HDP, PMMA, HMWP, all that type of material can be converted into a filament in different